All right, in this video, part 2, we are going to take a look at several examples of proving some identities here. Okay, so take notes. Again, hopefully you're taking attendance online. Okay, let's take a look at this example over here where we have to prove sine theta plus cosine theta squared equals 1 plus sine 2 theta. Okay, so you choose one side if you remember proving identities. You pick one side, usually, but not always. You choose the side that looks like it's more complicated. Even if you choose a side, if you feel like you're getting stuck on one side, then, try using the other side, okay? All right, so I'm going to use this one. So sine theta plus cosine theta squared. So I'm going to do this the quick way. If you don't remember how to multiply this out in your heads, just remember that sine plus cosine squared is just sine plus cosine times itself. Okay? All right, so I'm going to do it in my head. So I get sine squared theta plus 2 sine theta cosine theta plus cosine squared theta. And then I see a sine squared and cosine squared. Whenever you see those being added, they equal 1. Sine squared plus cosine squared equals 1. That's one of our Pythagorean identities. So we get 1 plus 2 sine theta cosine theta. And this here is what we just learned, which is our double angle for sine. So this is sine 2 theta, and I believe that's the other side. It is. Okay. All right. Let's take a look at another one. Let's go ahead and prove that 2 sine 2x equals 4 over tangent x plus cotangent x. Okay. I think I want to try it with this side. So let's choose this side. Okay, so 4 over tangent x plus cotangent x. I'm going to go ahead and change everything to sines and cosines. That's always kind of a good place to start. Okay, so that's sine x cosine x plus cosine x over sine x. Okay, and then here, now I've introduced these fractions within this bigger fraction. So I'm going to go ahead and get rid of them by multiplying by the LCD, sine x and cosine x. So I want to cancel out the sine that's here in the denominator. So I'm going to multiply by sine. But I also want to get rid of this cosine here in this denominator. So that's why I'm multiplying by cosine. But I also have to do it up here. Nothing cancels up there. Okay. And so now I get 4 sine x cosine x all over, what do I get here? Sine times sine, that's sine squared. Cosine times cosine, that's going to be cosine squared. Oh, sine squared plus cosine squared, we get that 1 again. So 4 sine x cosine x. But this is just 2 times 2 sine x cosine x. And 2 sine x cosine x is our, again, double angle for sine 2x. Okay, so this one verified. We want it to say 2 sine 2x, and it does. Okay, let's try another one. Okay, so let's prove that sine 2x equals 2 cotangent x over 1 plus cotangent squared x. Okay, so it looks like we would start with this side. This looks like a good place to start. Okay. All right, let's see what we get. 2 cotangent x all over 1 plus cotangent squared x. Okay, so, down here, whenever you see ones and squares, there's a high chance that it's probably a Pythagorean identity, and this one is. So 2 cotangent x in the numerator. Down here, this is actually equal to cosecant squared. Okay, cosecant squared. All right, so now I'm going to, this is like 1 over cosecant, right? 1 over cosecant is sine, so I'm going to rewrite that as sine squared. And then here, cotangent x is cosine x over sine x. Okay. And then here, one of these will cancel with one of these. So I get 2 cosine x sine x, and that's our double angle for sine. Right? Yeah, double angle. Okay. Let's try another one. Prove cosine 4x equals 8 cosine to the fourth. That's not a 4x, that's to the fourth. That's an exponent. Minus 8 cosine squared x plus 1. Okay? All right, so the thing about this one is that it actually might be easier to start with cosine 4x instead of starting here. I only know this because this is my second take on this video. I had to delete the last one, the original one, because I was cursing. So, because I wrote the problem incorrectly. Okay, so anyway, so it turns out that starting with the cosine 4x is actually a good place to start. You could try it doing this way. To me, I think it gets a little messy very fast. Okay, so cosine 4x. All right, so cosine 4x. We're going to use the double angle formula. So here, let's put a little note over here on the side. Cosine 4x, this is like our double angle. Okay, so this is like cosine to 2x. Okay, where this is usually our a, right? Our cosine 2a. And we have 3 choices as far as what we can use when we have cosine double angle, right? We can use cosine squared minus sine squared. Usually we put a here, but I'm going to write 2x. And same thing here. Usually we put a, but I'll put 2x. So that's our first choice of formulas. The other one has just the cosine in it, and that would be 2 cosine squared. And again, usually we put a here, but I'm going to put 2x since a is 2x. And then the other one, the third one, uses just the sign. So 1 minus 2 sine squared. Again, usually a, but a is 2x in this case. All right, so this is just sort of a little side note. That way, when we use the double angle formula on cosine 4x, we'll be using one of these here. Okay, so I kind of just simplified it for you a little. Okay, so cosine 4x, and we're going to try to expand it so it looks like this. Notice how the angles are all just x, not 4x, not 2x, simply x, which tells me that we're probably going to use the double angle twice. All right, so cosine 4x. Since we only have cosines here, I'll use the second option instead of the first or third, which require sine. Okay. All right. So 2 cosine squared 2x minus 1. Okay. Okay. So then now, so this here, whether I have the square right in there or out here, they mean the same. So let's just keep that in mind. Okay. And I want to get rid of this 2x because remember, these are in terms of x. So now I'm going to use the double angle formula, the original one. And I'm going to use the one that says this. Cosine 2x is 2 cosine squared x, single x, minus 1. So I'm going to use this one. Okay. All right. So 2, and then it's 2 cosine squared x minus 1, quantity squared minus 1. Okay. And now I'm going to go ahead and multiply this out. 2. Okay. So square the first term, 4 cosine to the fourth x minus double the product. So 2 times 2, 4 cosine squared x, and then square the 1. Now I'm going to distribute the 2 that's out here. Distribute it. 8 cosine to the fourth x minus 8 cosine squared x plus 2 minus 1. Getting close. I have this. I have this. 2 minus 1. If I do that last little bit, 2 minus 1 is 1. And there we have it. Okay. Again, if you're wondering how I got this part over here, remember to square this means 2 cosine squared x minus 1 times itself. So here, let me put a little arrow here for those of you who are wondering what I did here in this step. So note that 2 cosine squared x minus 1 squared is 2 cosine squared x minus 1 times itself. And you should be able to multiply that on your own, combine like terms, and you'll get this trinomial right here. Okay? All right. Made it through without any cursing. Good so far. Okay. At least on my end. All right, prove sine 2x minus 4 cosine x sine cubed x equals sine 2x cosine 2x. All right. Let's go ahead and choose this side. You can try the other side. I'm sure you can get to this using this side as well. I'm going to choose this side. Okay, so sine 2x cosine 2x. It doesn't matter which side you choose. Okay, so long as you can manipulate it to look like the other side. Okay, sine 2x cosine 2x. All right, so we have double angle on the sine. Here, let me do this, and I'll do it in colors so that you can see which one belongs to which. Okay, so sine 2x and cosine 2x. Okay, so that's what we have, sine 2x, cosine 2x. So I'm going to do the sine 2x first. Okay, so the sine 2x is just going to be 2 sine x cosine x. That's a double angle for sine. The cosine 2x, well, let's see. I have a sine, I have a cosine. I need more. It looks like I need more. It looks like I need more sines. I don't need any more cosines. So when I use when I choose the 3 of the 3, So I'm not going to choose the one that has cosines. I'll choose the bottom one, 1 minus 2 sine. Okay, uh, so I'm doing this part here. Cosine double angle is 1 1 minus 2 sine squared x. Okay. I chose the third one because I don't have a whole lot of cosines here. So if I use the other two, remember the other two have cosines in them. And I don't want to end up with a bunch of cosines I need to figure out. Okay. All right. Okay. So that's how I do that first step. Now I'm going to go ahead and just multiply. I'm going to multiply this with these over here. Okay. All right. So I get 2 sine x cosine x. And then 2 times 2 is 4 sine cubed and cosine x. Okay. And are we getting closer? Okay, I have this part right over here. Oh, and this part is actually sine 2x. So this is sine 2x. 2 sine x cosine x is double angle, right? And then now I have this, and I'll just switch their order since they are commutative. And there we go. Okay. All right. Let's do one more. I think it helps to see a lot of these done. But this was one of my favorite things to do in trig when I was a student, doing the proving of identities. All right, let's try this one. Tangent theta equals 1 minus cosine 2 theta over sine 2 theta. Okay, so I'm going to choose the right-hand side. All right, 1 minus cosine 2 theta all over sine 2 theta. All right, and then I'm going to use my double angle. I'm going to use my double angle on the cosine, and I'm going to use my double angle formula for the sine. Okay, so that's going to give me, all right, so let's see. I have 3 options for the cosine one. Since I want to end up with tangent, I'm going to use the one that has sines because tangent is sine over cosine. So let's see what happens if I do that. Okay, so that's my third, that would be the third option. Okay, so that's going to be 1 minus 2 sine squared theta. Just double check. Yeah, 1 minus 2 sine squared. And then sine 2 theta, that's just 2 sine theta cosine theta. Okay. All right, now let me go ahead and do this distributive here and combine like terms. So 1 minus 1 plus 2 sine squared theta over 2 sine theta cosine theta. All right, these guys cancel. This is looking good. Okay, 2 sine squared theta, 2 sine theta cosine theta, and the 2's cancel. And one of these cancels with all of that. Oh, and there we go. We have sine theta in the numerator, cosine theta in the denominator, and we know that that is tangent theta. Yay. All right. Okay, so as far as the test goes, I gave you all multiple choice questions. So if you're struggling with these identities that you have to prove, keep in mind that on the test, it's kind of like they have it done for you. You just need to fill in the blanks, like certain parts will be missing. Okay. All right. If you have any questions, make sure you email me or you text me.